Hi everyone, welcome back, and we are today talking about limiting reactant. All right, this is going to go on page 28 in your interactive science notebook. So as we get started, you should flip to the front for your index, and you're going to, under the box for L, write limiting reactant. It's important that you guys are keeping up with that because your culminating activity will have a lot to do actually with limiting reactants. So this is going to be a great page of notes for you to look at as you complete that culminating activity in just a few weeks here. Okay. So go to your page 28. You go ahead and write limiting reactant. You're going to write today's date, and you're going to write page number 28, and we're on the B side. So limiting reactant, you kind of have to get your head around what this means as you are calculating it to kind of understand where it's coming from and to understand what you are doing with this data. So you can go ahead and copy down the definition. We're going to say limiting reactant is a reactant that determines the amount of product that is formed. So I'll talk to you a little bit more about that, so you can go ahead and pause right now and copy that down. Okay, so limiting reactant, let's take a real life example. Now this might not be exactly the way you make a peanut butter and jelly sandwich, but we're just for the sake of argument going to say that a peanut butter and jelly sandwich recipe is 2 pieces of bread, which you can see right here, and 3 scoops of peanut butter. Okay, I like mine nice and peanut buttery. And then 1 jelly. I don't like too much jelly because I'm already sweet enough. Then that's going to make 1 sandwich. So we can think of this like a synthesis reaction, right? We're going to take individual pieces, we're going to put them together, and we're going to synthesize 1 thing, and that's going to be the peanut butter and jelly sandwich, okay? So let's say we have to follow the same exact recipe, and you go into your cupboard at home and you're like, well, I've got 4 pieces of bread, an entire jar of peanut butter, and an entire jar of jelly. If you had to make as many sandwiches as possible, what's going to run out first? Obviously the bread, right? The bread's going to run out first, and you can only make a total of 2 sandwiches because each 1 sandwich requires 2 pieces of bread. If I have 4, I'm going to make 1 sandwich with these 2 and 1 sandwich with these 2. And because I have so much peanut butter and so much jelly, I know those aren't going to run out. It's actually my bread that's going to be my limiting reactant. So if in a different scenario, say you've got loaves and loaves of bread, you have only a little bit of that peanut butter left. You've got 9 scoops left in that jar, but you still have this entire jar of jelly. So once again, because you have tons of bread, you have tons of jelly, but you are limited by only 9 scoops of peanut butter, how many sandwiches can you make? Should be 3, okay? Because you would use 1, 2, 3 of the peanut butter. Okay, so basically what I'm getting at is we're going to be looking at our recipe and determining how many products we can make based off what piece of our recipe is going to run out first. All right, in this case, again, tons of bread, tons of peanut butter, but only 1 scoop of jelly. So how many sandwiches can we make? Well, only 1. Okay. So one last thing, just to kind of relate this a little bit to something you probably may have done in the past before. I don't know about you guys, but whenever I make my cookies at home, because I really like making cookies, I always get all the ingredients out first because it has happened to me that I'll be halfway through making my cookies and I'll be like, oh, I don't have enough flour, or I don't have enough of one of the ingredients. And then I'm like, well, darn, now I have this whole recipe I have to throw away basically. So sometimes what I will do is I'll take everything out and kind of check to make sure, do I have enough of everything on the recipe, right? In this example, this is your chemical reaction. This is all the ingredients going into your product. And then it can tell me how many cookies I can make at the end. So sometimes what will happen is, oh, I don't have a cup of butter. I actually only have half a cup of butter. So what should I do? Well, if I only have half a cup of butter, I'm going to cut all the other pieces of the recipe in half. And in the end, I won't make an entire batch of cookies, I'll make half a batch of cookies. So if you've done something like that in the past before, then you've essentially done stoichiometry and you've essentially done limiting reactant. You identified, oh no, I don't have enough of one of my ingredients that's going to limit how many cookies or products I can make. Okay, so let's see what that looks like, not with cookies and peanut butter and jelly and all that stuff, but with chemical reactions. So copy down the question, what is the limiting reactant when 80 grams of copper reacts with 25 grams of sulfur? Okay. This is a wonderful example for something like what you will do for your culminating activity. Notice all the information I gave you are what your reactants are. I didn't give you a chemical reaction. I didn't balance that chemical reaction. And I didn't tell you which one is your limiting reactant. You're determining what that is. So what you're going to do is you're going to first start with a balanced chemical reaction. So we're going to take, in this scenario, copper, and we're going to add it to sulfur. So think back, what kind of chemical reaction would that be? It's going to be synthesis, because you're taking two things and you're combining them together. So your reaction should look like this. We should say copper plus sulfur. And in this case, I'm using copper 1. So that means that my formula would be Cu2S1. Where did this 2 come from? Came from the sulfur. Okay, sulfur has 6 valence electrons. Wants to get 2 more, so that's a charge of 2 minus. Okay, you're gonna have to remember all of this stuff, so make sure you guys are keeping fresh on it. Then, is this a balanced chemical reaction? Nope, because in this side, I've got 1 copper, 1 sulfur. On this side, I have 2 copper and 1 sulfur. So it's an easy fix. I'm just going to put a 2 in the front of copper. Now I have a balanced chemical reaction that I can work with. Okay, so that's going to be kind of like your first part of your culminating activity. Okay, so now I'm going to be able to determine limiting reactant. What pieces of information do I need? Well, I've circled right here that I'm starting with 80 grams of copper. And I circle right here that I'm starting with 25 grams of sulfur. So once again, we have to remember the fact that comparing grams of one substance to grams of another substance is a lot like comparing apples and oranges. Each of these things has different molar masses, so we have no idea really how many like atoms or molecules we're dealing with if we're just basing our measurement off weight. So we know we're going to have to convert to moles. We know we're going to have to use this chemical reaction to relate them to each other. But more specifically, what we're going to be doing in the end is we're going to see how much product can be created from each amount of beginning reactant. Okay, so essentially I'm going to take the 80 grams of copper and I'm going to determine, okay, how many grams of my product would that create? Then I'm going to take 25 grams of sulfur and I'm going to determine the same thing. How many grams of my product will that create? And just like we were looking at peanut butter and jelly, like what thing is going to run out first, we kind of said, okay, well, this one would make 4 sandwiches. This one would make 3 sandwiches. This one would make only 1 sandwich. And we were limited by whatever reactant ran out first. That's what we're looking at here as well. We're going to figure out which one is going to make the smallest amount of product because that's the one that's going to run out first. Okay, so let's take a look at what we would do mathematically to figure that out. Well, like I said, we're going to take each of our amounts we're starting with, and we're ultimately trying to figure out how much of our product we will get out if we start with this amount. Okay, so we're going to have to do 2 stoichiometry problems, gram to gram. Okay, fortunately, we've had so much practice with that you guys are doing really well with it. So I'm going to zoom through how we do a gram to gram stoichiometry problem because once again, I've done plenty of videos on it. You guys have done plenty of practice with it, but please let me know if you guys have any questions, okay? So we're going to say what goes up must come down. Okay, and I've already told you guys that this will be 63.55 because that's the molar mass of copper. And I'm converting that into moles. So I'm using 1 mole of copper equals 63.55 grams. Great. Now to get to moles of my second substance, which in this case is going to be the product, I'm going to say what goes up must come down. The 2 here comes from the fact that there are 2 coppers in my chemical reaction. And I'm ultimately trying to change this to moles of my product. The 1 here comes from the fact that there's 1 copper sulfide in the product. Then lastly, I'm going to convert this to grams. So I'm going to say once again, what goes up must come down. So moles of copper sulfide are on the bottom. Now remember the 1 is here just because we're doing a mole gram conversion. So I'm always talking about the molar mass of 1 mole of my substance. Okay, so I am doing a gram conversion here. So I've already done this work for you. To get 159.17, I took 2 times the mass of copper plus 1 times the mass of sulfur, added it together, and I got my molar mass. Okay, so we're going to take 80 times 1 times 1 times 159.17. We're going to divide that by the total of 63.55 times 2 times 1. Okay, if you plug it into your calculator correctly, you should get 100 grams of copper sulfide. All right, now let's take a look at the second product. So this is saying, by the way, that if I were to react all of these 80 grams of copper and I didn't have any problems with my amount of sulfur, no, the other ingredient is not running out, then I would create a total of 100 grams of my product when I used all of that 80 grams of copper. Okay, so let's see how much of the product would be created by the 25 grams of sulfur. We're going to say once again, I'm going to walk through gram to gram stoichiometry. We're going to say grams is up, grams goes down. The 32.07 for sulfur, it comes from your periodic table. And at the top, we're going to say we're converting to moles of sulfur. And this is the molar mass of 1 mole of sulfur. Right? Next step, we use our mole to mole ratio. So I'm going to say what goes up must come down. In my chemical reaction, there's 1 mole of sulfur. In the top, I'm going to be converting from moles of sulfur now to moles of my product. So at the top, I have 1 mole of copper sulfide, again, because there's nothing in front, so that means 1. All right, and my last step is to convert from moles of copper sulfide to grams. So I'm going to say what goes up must come down. And because this is a mole gram conversion, I am going to have grams at the top. And once again, I can just use the same value. I already calculated that. And I know that I'm using 1 mole of copper sulfide, so per 159.17 grams. Okay. So I'm going to take 25 times 1 times 1 times 159.17. I'm going to divide that by 32.07. Okay, and then times 1 is the same thing, so we're good. All right, in this case, I get 124 grams of copper sulfide. All right, so to determine which one is my limiting reactant, I'm thinking about which one produces the least amount of product. Okay, the one that produces the least amount of product in this case is obviously copper. It's not something where I could have looked at the question and just been like, oh, well, there's less sulfur, so that must be my limiting reactant. It's actually not the case, right? Because this much sulfur actually produces 124 grams of my product if copper was in abundance. This much copper only produces 100 grams of copper sulfide when we have abundance of sulfur. So we know that because this one produces less, this is the substance, copper, that's going to run out first. Therefore, copper is the limiting reactant. Therefore, sulfur is what's called the excess reactant. Okay, so go ahead and copy down that copper is a limiting reactant because it will run out first. How do I know it will run out first? It makes less product. Sulfur is the excess reactant because it makes more of the product. Basically, what's going to happen is copper is going to be able to produce this much of the copper sulfide, and you'll end up having leftover sulfur. Just like if I only had 9 scoops of peanut butter, but an entire jar of jelly, I would use up those 9 scoops of peanut butter to make my 3 sandwiches, and I'd obviously have leftover jelly. I would not use the entire jar. Okay, so underneath that, please write down your steps and reminders, especially so that you can use this during your culminating activity. You're going to say, number 1, use stoichiometry to convert quantities of reactants to quantities of a product. Okay, make sure that it's the same product for both of your reactants, because it wouldn't make sense to compare different products. There's going to be times where chemical reactions will have more than one product, right? Pick a product and stick with it. Whichever reactant produces less of the product is a limiting one. So make sure that that's what is clear to you in your notes. If it produces less, it will run out first. And then the whole point of figuring out which one is your limiting reactant is every stoic problem that you have about that particular reaction is all going to be dependent on your limiting reactant. So once you've determined what it is, you're going to always start with that quantity and substance for any other type of comparison that you're trying to do. Okay, so now let's use these notes for a practice problem. So get to the left side of your page, page 28A. Again, this will look something like what your culminating activity is going to look like. So you copy down the fact that you've got 1.7 grams, that's supposed to be grams, this little g, sodium reacts with, oh, and I'm sorry, this I was supposed to change to a 4, and I totally forgot. So write 2.4 grams of chlorine. Okay, it gets fixed in the next slide, so hopefully that's clear. Yeah, there we go. That's what I meant to say. All right, so the very first thing that I'm going to ask you to do is I'm first going to ask you to come up with a balanced chemical reaction. So pause and do that. All right, we've got sodium and we've got chlorine coming, are our 2 reactants. So you should be able to surmise that you will have a synthesis reaction for this one, and your product should be NaCl. Okay, here's the deal. Did you remember that chlorine is diatomic and therefore needs a little 2 when it's on its own? And did you remember that sodium chloride, when you crisscross your charges, this is a 1 plus, this is a 1 minus, so you should just have sodium chloride. It's important to know that because you would then need to balance. If you didn't do this correctly, you wouldn't need to balance, but you do need to balance if you do it correctly. So that just means you're going to have to throw a 2 in the front here. Okay, that's going to affect our stoichiometry, which ultimately will affect which one's the limiting reactant, right? So remember to determine the limiting reactant. We are going to take each of these substances that we were given, and we are going to find how much of our product those amounts of the reactants would make. So we're going to set up next a stoic problem for each of my reactants. So I'd love for you to pause the video and try it out here, just to kind of check to see how you're doing with gram to gram stoic. It's one more time for me to walk through it with you. So pause and try it out. Okay. So again, I'm just going to check your work here and give you very brief explanations. If we're starting with 1.7 grams of sodium, then we're going to say grams of sodium at the bottom. There's 22.99 grams of sodium in 1 mole of sodium. All right, there's your gram to mole conversion. Next step is mole to mole conversion. So we're going to say that for every 2 moles of sodium in my chemical reaction, there will they will produce 2 moles of sodium chloride in my chemical reaction. And last, I want to convert my moles of sodium chloride to grams. So 1 mole of sodium chloride is 58.54 grams. So when you multiply across and divide your top by your bottom, you should get 4.3 grams of sodium chloride. All right, for the second one, if you've got grams chlorine at the top, you're going to drop down and put grams chlorine at the bottom. Now, did you remember that the mass of chlorine, when it is by itself, because it's diatomic, is 70.90? Remember, if there's a little 2 by your formula, that does mean you have to double the mass. So you should have said 70.90, okay, in 1 mole of the chlorine molecule, okay? Then we're going to go from mole to mole by using our mole to mole ratio from the balanced chemical reaction. So in 1 mole chlorine, we'll produce 2 moles of sodium chloride. All right, and then this step here you'll see is going to be the same because we want to compare it to the same product, right? So we're going to say what goes up must come down. In 1 mole of sodium chloride, there's 58.54 grams of sodium chloride. All right, and once again, we're going to multiply everything across, and then we're going to divide by everything at the bottom. You should have got 40 grams of sodium chloride. All right, so then what's your limiting reactant? If you take a look here, 1.7 grams of sodium will produce 4.3 grams of sodium chloride. 2.4 grams of chlorine will produce 4 grams of sodium chloride. So remember, whichever reactant is going to produce less of your product, that is your limiting reactant. So it's chlorine. Okay? So hopefully this makes sense. If it doesn't, maybe try watching it again. We are going to practice this Monday. We're going to practice this Tuesday. I will be available for tutoring on Wednesday, and then we will take a quiz on it on Thursday. So we are working on this for quite a while here. I want to make sure you get it, but thanks for following along and trying your first practice with me. I'll see you guys next week.